over the world. This is again, I'm a senior journalist. Now I'm going to present to you another problem solving regarding reaction kinetics. Problem number 3. In the chemical reaction, 2 moles of nitrous oxide plus 2 moles of hydrogen gas is equals to nitrogen gas plus H2O. What is the value of rate constant, overall reaction order, and reaction order of NO concentration and H2 concentration? Okay, so we have and this is our data. This one, experiment, this one. Okay, experiment 1, experiment 2, experiment 3, and then we have our NO. Okay, H2 and the rate constant. So there are values and data here. Okay, so no, sorry. Oh my gosh, sorry. Show you the reaction. It's gonna be like this: 2 moles of NO plus 2 H2 and 2 plus H2O. Like this. Okay. This one is the reaction. Okay, I don't think so this is balanced. Okay, but this is not our focus to balance because we are not dealing in the stoichiometric relationship. So if we balance this, so much better. But in this reaction, we don't need to balance perfectly. Let's just proceed directly to what are being asked and what are being required for this particular problem. Okay, so our K, rate constant. Okay, overall reaction order. And then N for NO and N for H2. So these are our what are being asked. Okay, like that. Okay, so the problem states what are the rate constant, overall reaction order, and reaction order with respect of each reactant in O and H2. Now, if you take a look for the experiment for this, you can there are data, right? So we need to use this equation. Rate low is equals to K NO M, let's say, and H2 and okay. So this will be our formula to be used. Rate is equals to NO raised to the power N and H2 raised to the power N. So let's change the N for H2. And this is M. Okay. M for NO and H2 is N. I'll change because in our rate law, M is for NO and H2 is for N. Okay, like that. So in here, we need to individually check the concentration. Okay. Here, starting from NO, from 0.15 to 0.30, you have to multiply a factor of 2 here, the rate law of NO. So it's gonna be like this. Okay, NO and is equals to the rate, right? So we have 0.15 times 3 is equals to 0.30. So NO raised to the power n, so the concentration times 3, okay, factor of 3, so that we can obtain a 0.30, which is reflected here. Okay, which is reflected here. So 0.15, then 0.30, so 0.15 times 2, 0.15 times 2 is equals to 0.30. Sorry. Two pala siya. Okay, okay. Ano naman siya? 0.30. So, times 2 lang siya. Our initial data is 0.15 man siya. Molar. So, 0.15 times 2, 0.30. 0.15 times 2, 0.15 times 2, 0.30. Okay? So, initial concentration of NO times 2. So, 0.15 times 2 is equals to 0.30. Our R is 0.84. Okay? 0.84, okay, to 3.38. So you should multiply, how much you will multiply by 8.24 in order we can get 3.38. Okay, so this one, so let R is equal to the factor to be multiplied by 0.84 so that we can obtain 3.38. So 0.84 times R is equals to 3.38. So 3.38 divided by 0.84. So we have 4.02, or simply 4. Like that. Okay. See? So initial concentration times 2 is equals to 0.30. Okay. That's basing on our data. Okay, you need to multiply the initial concentration to 2 in order to get 0.30 molar in that second trial of the experiment. And then we have the R. So it's very difficult to multiply that in a whole number. So we need to let R as our factor to be multiplied. It will be equal to the 3.38 rate constant of the second experiment. So 0.84, the rate constant for the first experiment, times R is equals to 3.38. So R is equals to 4.02 or 4. Just like that to avoid the point. Okay? So 4.02 or 4. Okay? Like that. So, we need to substitute now the factor being so factor of 2 raised to the power n is equals to 4. Okay, 2 raised to the power n is equals to 4. So we need to multiply this by something in order it become 4. So 2 times 2 is equals to 4. So n is equals to 2. N is equals to 2. Okay. Or m, because we let that as m. Okay, at first. Sorry. So we have 2 here. So reaction order already is NOM is equals to 2. This is second order. Okay. The NO, okay, initial concentration of NO order with respect to this is 2. Second order ang NO. Okay, H2 na punta. Okay, H2 raised to the power n. Now sa H3. So, check here. In our H2, there's no change. Do not focus on the initial concentration that has no change. Focus to the concentration that has changes. So, from 0.15 to 45. So, what you will multiply to 0.15 to get 45, that is times 3. Okay? Times 3. So, that is 0.15 molar times 3 is equals to 0.45. Okay, our 0.15 here in the H2, okay, here, our 0.15 times 3, so that will be equal to 0.45 molar. So 0.15 times 3 is equals to 0.45. So this 3 is our factor, like this. Okay, H2 times the factor of 3, so that you can attain a 0.45 in the last experiment number 3. Okay, now our R will be, okay, here the R also is 0.84, so that we can attain of 2.53 here. If you use here the first, use also here. Okay, second. So we need to have 0.84 times the factor of R, which we don't know yet, is equals to 2.53. Okay, just like this. Okay, 0.84 rate constant in the first experiment times R, which we don't know, is equals to the 2.53 in the last experiment. Okay, rate. So R is equals to 2.53 divided by 0.84 is equals to 3.01, or just equals to 3, huh? So our R is equals to 3. Okay, so if our initial concentration will be multiplied by 2, our R will be multiplied by 3, something like that. So we have substitute now the factor that we will multiply. So 3 and is equals to 3. This one, 3 raised to the power n is equals to 3, because the rate is 3. The factor times the factor of 3 in the rate law here, and here also times the factor of 3 in the initial concentration. 3 raised to the power n is equals to 3. So common ang base 3, so that's 1. Okay, 1. Therefore n is equals to 1. Therefore n is equals to 1. Okay, so our H2, initial concentration of H2 is equals to 1, reaction order. So substitute that here. So may reaction. Okay, so R is equals to KNO raised to the power 2 and n raised to the power 1. So our K is not yet solved. Our value of K is not yet solved, but our overall reaction order will be 2 plus 1 for this NO, and that's 2 is equals to 3. Overall reaction order is equals to 3. This one. Okay. 3. Reaction order of NO is equals to 2. Okay. Reaction order of H2 is equals to 1. Okay. Reaction order of NO is equals to 2. Reaction order of H2 is equals to 1, in which we solved a while ago. Overall reaction 1 plus 2 plus 1 is equals to 3. So K is our problem now. K. So R from this equation also. So R is equals to K NO. Okay, raised to the power 2 and H2 raised to the power 1. Okay. Use this equation to solve for the rate constant K, and take note this is initial concentration and initial concentration also, so meaning these are all initial, so meaning this is used in a data 1 or trial 1 in the experiment, or experiment number 1. Substitute these values here, all this one, this one, and this one, because this is initial data trial experiment number 1. Okay, so we have R, so K is 0.84. Okay, NO is 0.15 raised to the power 2, H2 0.15. Okay, like this. And then 0.84. Okay, So K is equals to 0.84. So 0.15 times 0.15 times 0.15 is equals to, okay, so 0.84 divided by 0.00375. K is equals to 0.15 times 0.15 is equals to 0.0225. 0.15 times 0.0225 is equals to 3.375. So 0.84 divided by 0.00375. Okay, our K is 224. Okay, so from here, the rate law, substitute all the datas. Okay, this is the initial concentration sa ating experiment. So R is equals to K, and then substitute all the value, and K, solve for the value of K, so K is equals to this quantities here, and then we can obtain the value of 2, 2, 4. Now our unit, we don't know yet, so just supply the units each and then cancel. Okay, this is meter per second, and then meter squared, and this is second. So cancel, cancel. So like this, wait for a while, and seconds. So sorry, this is m also. So m cube. So like this. So cancel, cancel. So 1 over m 2, okay, second. So this is our unit for the K, 1 over M2S. It's gonna be, I think, to second order. Let's check. Okay, so K is equals to uh, M minus 1 minus over a reaction order of 3 times T equals to the second, so -1. So it's gonna be this one now, like this. This is our unit for K. So our answer will be 224 1 over m squared to the s. Okay. Okay. This is the value of K. 224, so I will write now here. K is equals to 224 1 meter squared. 1 meter squared. Molar squared. This one. So this is our answer on. Okay. So we've solved everything now. The rate constant K is equals to 224 over 1 meter squared over second. Okay, the overall reaction order is 3. The NO reaction order is 2. The H2 reaction order is 1. Okay, like that. Okay. So it's gonna be like that. If we solve to the value of n for this equation, then we can solve also that through the formulation of K. Wait for a while. Like that. Okay, let's just prove it. So K is equals to m 1 minus n t negative 1. Then K is 224 1 meter is equals to m 1 minus n t. Okay, 224 t is equals to m squared s. Okay, m 1 minus n. Okay, so 224, that is seconds, is equals to m is squared s m 1 minus n. Cancel, cancel. So 224 is equals to m, okay, m2 is equals to m n 2n. Okay, so 224 is equals to m common, so 1 1, so 1 m, so it's 2, and then negative 2n, like that. Okay, so 224 is equals to m, 1 minus equals to, this is 1 to negative n only. Okay, so 224 is equals to so n, so 224 uh, is equals to m 1 minus n, like this. Okay, so how can we solve this one? So if we try to have a value of, let's say, m for the molarity of the initial concentration, let's assume, so 0.15, so 0.15 to 24, or we can have that one as 0.15 negative n equals to 224 negative, so we have uh, negative n is equals to x. Okay, and then 0.15 equals to 224, so 0.15 to 24 is equals to nx. Okay, so 224 divided by 0.15. Okay, so like this, so 0.15 224 224 divided by 0.15 equals to 4.93. So here n is equals to 3. Ganon. So where n is equals to 3. Okay, from this formula we solve for the value of n. Okay, so n is equals to 3, so third order overall reaction. Actually we don't need to prove that our n, what is the value of n, but because it's already obtained in the solution, which is n is equals to 3, the overall reaction, in which that's k. Okay, I'll try to prove. Okay, and n is equals to 3, something like that. Okay, that's it. Thank you so much for watching. I hope you like this video. You can subscribe my YT channel if you want to. Thank you so much. Bye bye, God bless everybody. Thanks for watching. So overall reaction order is 3 for that reaction. Okay.